I think you have the procedure of playing the banners and everything, right?
Hi guys, so my name is Velda Kiara. I'm representing GDG Nairobi, and I'm going to be the moderator for the day. Today on our cloud section, we're going to have going serverless, the non-committal way, that is Introduction to Clean Backend Architecture in 2020. And our speaker will be Gente Russell, I think, yes. So yeah, and if you have any questions, please feel free to leave them on the comment section, and then we'll get back to you as soon as the session is almost done, so you get to answer all your questions. And I have a co-host today, Ruby. Hi, Ruby. So, yes, welcome to our session. Ruby, I think you can say a few words before we begin.
Hey guys.
And Gente is also here. So, yes, let's begin. So,
I think I can. Yeah. So,
okay.
How are you, everybody? I was introducing myself. So, my name is Ruben. I'm from GDG Nyeri. I'm a software developer, and I'm happy to be here. Thanks.
Okay.
Yeah, let's
so
take
our
it
guest
away.
is Gente Russell. He is the CEO of Elewa Company. So, welcome, Gente.
Thank you for inviting me also. Okay, it looks like the screen has been moved to me, so yeah, maybe I will just share my screen, and I made a small presentation, and start the meeting from there, if that's okay.
Yes, sure.
Okay, let me go. There you go. So yes, what I wanted to talk about today, first of all, thanks everyone for inviting me and joining this session as well. Is basically going serverless without commitment. From a background that we're talking a lot about these new types of ways of how to run applications in the cloud. I think the cloud over the last years has evolved tremendously from what would be the early cloud, the virtual machines, to the containers, which were already a bit more reusable, to this whole trend of serverless that's going on right now. But we look at it in such a way that, okay, if we're going to try out of these new technologies, which are still quite new. I think serverless has not been around for that long. So if we are going to take the risk of moving our applications from our old type of hosting to this new serverless type of hosting, how can we do it in such a way that we basically reduce the risk and not have to commit completely to these platforms? What if we want to try out multiple platforms? What if we want to try out different ways in on which to basically engage with them? Now, before I do that, just a bit about myself. There were supposed to be 3 icons, okay, but one seems to have some sort of an effect. There it goes. But I'm a computer scientist by trade, but an educator by heart. So I'm the CEO of Elewa Company Limited. We're actually active in Kenya, where our head office is. Myself, I'm in between, as you can see on the left, Belgium, where I am right now, and Kenya. And I'm a computer scientist that focuses a lot on architecture, so on clean architecture. How do we basically build things that are sustainable in the long term, so that we can survive, what we're talking about for example, for today, can survive multiple ways in which they're deployed, can grow organically, and are continuously able to change. I'm a bit of a versatilist myself. Next to that, I do a lot of very different things. At the level, we're very into education, so we develop educational platforms for different types of organizations, all the way from schools to larger organizations that, for example, support schools or support professional education. And we also run a bit of our own education sort of mini school inside of our organization. So what we run is something called the High Potential Software Engineering Apprenticeship. So it's a 2-year program where we basically do on-the-job training to get people that are at the junior software development level to maybe the level of a lead, meteor, or even all the way up to senior. It's a very personalized learning trajectory where we basically look at, okay, these are all of the different types of software engineering that are out there. Where do you want to grow? Where do you want to where do you see yourself? So we go all the way from my specialty, which is architecture, to quality, to machine learning even. And we work on exciting projects. So we do both projects that we have internally as a level that are being done as we're going through the apprenticeship, as well as we run basically the tech stack of startups across the world. So as part of this program, basically one of the things that we're looking at today is what what we're looking at today basically is going to be the backend, and we're not going to do it from. I'm not going to explain too deep into detail what serverless is. I don't know if people have already been acquainted to it, but I can explain it maybe in one sentence. It's basically that with serverless, we no longer have to care about where things are running. They'll just run for us. And I'll explain this a bit later when we go back into code. But we'll talk about the backend in general. And we'll talk about it from my perspective, so my head, which is that of maybe an architect, of a software architect. So as a software architect, what we basically want to do is we want to look at how do we build the application at several levels of its, at several stages of its lifetime. So when it's very small, when we're not, maybe as we're going through the several stages of a company, when it's very small, we don't have an MVP even yet. We need to optimize for very quick iteration, very quick development, very quick new features, testing them, changing the code without having to start again from scratch. So basically something that's very agile. And as we go, but that as we go up and get more customers onto the platform, get more people onto the platform, also can grow with you. So basically also can, is stable and can ensure that quality is assured for all customers at all times. So when we do that as an architect, we basically look at 3 concerns. I'm just talking about, I'm talking about the backend right now. We always will, I mean, Architecture 101 is basically that the first thing you do is you identify the different roles and responsibilities that are in an application and you start separating them. So that's, separation of concerns is what it's called. And I'll get back into what those, in those patterns later as well. But now looking at it from a backend, and I'm jumping straight in right now, there are 3 main concerns that we want to worry about. The first one is logic, and this is the most important one. What does our thing need to do? Which logic needs to be executed? What needs to actually happen? What's the business logic? How does this thing support customers or any type of targets? If we think about the logic, the next question is basically, okay, this is what needs to happen. When does it need to happen? Which is a separate concern. When does it need to happen? It could be that it's a REST service. So whenever I get an HTTP call incoming, I need to run this logic. Whenever I get, it could be also something like a topic. Whenever something happens, for example, a document gets updated in my database, I want to run this logic, etc. And then the last thing, the last concern, which is a separate concern, is the platform itself. So concerns that are part of the platform is how is it going to be deployed? Where is it hosted? How does it scale? Which is also an important consideration. What's the application context? Which types of things do I have access to? And how does it integrate maybe in the larger picture of the platform? So those are the 3 different type of concerns when it comes to backend. And when we identify these different type of concerns, we basically now go look at, okay, how do we develop applications that ensure that each of these concerns are separate. So when one changes, it doesn't affect the other ones too much. And and how do we engage with this platform? Now, we'll talk about basically how to do this separation. That's actually the target of this talk, the topic of this talk. But before that, a brief introduction to maybe architecture. I don't know if anyone here knows basically the solid principles of architecture, because software architecture in its sense, it comes down to five principles. They were invented by Robert C. Martin, which you can see on the left. He has a website, cleancoder.com, where he blogs a lot about software patterns and things like that. And it comes down to these 5 principles, which are the solid principles, single responsibility principles. So basically, every component within your code, similar to what we were going into in the previous slide, every component within my code needs to have a single responsibility, a single thing it handles. Open-close principles, so things need to be open for extension but closed for modifications, which is all of these things. Basically, you can look at them and really try to understand them at a later time. But there's also the list of substitution principles, so basically that you can swap out things without affecting the core. Interface segregation, which is a really important one for the topic of this call. We will basically always want to work against interfaces and not against actual implementations, which I'll show also later when I go through some codes. And then dependency inversion, which basically means that we want to control which implementation of our interface gets used. Controlling which implementation of your interface gets used is actually a separate concern, so a separate responsibility. Now, I'm going very quick over these. This is actually something I really recommend you look into. There's a really good Wikipedia page even. And all the time when we think about software architecture, when we think about how to look at our code from what I would call a meta level, so looking at our code from code, so how do I do something that just is stable over time? We look at these 5 principles and we apply these 5 principles to our code. Now, applying the single responsibility principle to these 3 types of layers basically means that each element should implement its own purpose and should not be dependent on the other elements. So what our code needs to do should not be dependent on when it needs to run. Of course, there's these links. If I have a cron job that needs to, a cron job, basically a job that happens maybe every day at 1 a.m., I mean, the requirement of it running at 1 a.m. is different from what it needs to do, is basically what this means. And the platform on which it needs to run, the actual server or the actual platform, is a separate concern from when it needs to run and what it needs to do. So that's basically just what the single responsibilities principle says, and how we want to start organizing our code as well. So we don't want our code, our logic, to be dependent on when and how. So just to look at it from this perspective, at the logic layer, we basically want any business logic in any format. So a single subject of execution. What that basically means is that this goes beyond this goes even beyond the logic you're executing. This is basically even any language that you want to write the logic in, you should be able to write the logic in. For example, at Aleva, we had a project last year which won the UNESCO ICT in Education Prize in Kenya and actually got finalists globally, where we use computer vision to basically automatically mark paper assessments of students in Kenya. So they fill in their assessments in paper. We take a picture of them or we put them through a scanner, and we can, using computer vision and AI, automatically mark them. Writing that logic, writing computer vision, it's best done in Python, because you have libraries at your such as TensorFlow, of course, which also has JavaScript, but is faster in Python from my experience. It has OpenCV, which is a library for computer vision. And it's easy to use Python to build that type of logic. But the rest of our application, for example, resides in TypeScript mainly, Angular on the front end. We have a whole lot of microservices that are running and doing other things, like now, when the data comes in, when the red data comes in, it needs to process it. So all of this business logic, all of this actual, you also want it to be able to run on the platform that it's most suitable for. So the business layer does not need to worry about how and when. It just needs to be worried about, what do I need to do? What is this logic I need to do? The behavior layer then, that's the one that now worries about when does this thing need to run. And as I said, you have different ways in which to do it. It could be a REST service. It could be GraphQL, if someone has worked with that. A cron job, PubSub, which basically means PubSub is a really interesting concept in Google Clouds, where I can basically just say, I mean, I can subscribe to a topic and say this has happened. So I publish to a topic, and then there's different listeners that start executing the moment this topic comes in. Practical examples I can always give later also to just give you an idea on what it looks like. And then the platform finally. The platform layer should not worry about what is being executed. It should just, or when it's being executed, it should just receive the input and schedule it accordingly. So basically, that's where you have a physical computer. So if we're running something on our local machine, whether we're running it on our local machine, whether we're running it on a VM, which is basically a complete local machine which we put in the cloud, whether we're running it on a Docker container or whether we're running it on a function, the platform is responsible for taking for how we want to run it and then making sure that it happens. If any of this is confusion, I maybe will just let it open to some questions before I go into code, and then we can have that discussion. We can also have that discussion after I present. But let's talk about cloud functions first. So basically, serverless platforms, what they're all about is that they take care of that platform layer completely for you. So they basically provide you with an API that gives you access to the platform layer, where you can basically schedule things onto the platform layer as you want it. They will take charge of now taking that code, taking when it needs to happen, and making sure it happens. So that's what a serverless platform basically means. We still have a server running somewhere, but it's not us who needs to maintain it. It's not us who needs to care about it. That's why we call it serverless. It's a very strange term that has actually been chosen, because if you look at serverless, serverless actually has infinite servers running. You have access to, for example, I mean, all of these big data centers you can think of. The bigger, the better. That's actually where your code will be running. It's millions of servers that are in such a platform. But because we don't need to care about the servers ourselves, we just need to care about when it needs to happen. So the behavior layer and the logic layer, we call it a serverless platform. So it basically comes down to you provide the code and they provide the platform. As I said, so there's different serverless platforms that have come up. We have Google Cloud Functions. We have AWS Lambda. We have Azure Cloud Functions, which is a recent one, I believe. And then we have, for example, also Alibaba Cloud Functions. And all of them are the same. You just provide them with code, a function, and they will execute it depending on your wishes of when it needs to execute as well. So in a serverless platform, these three layers, they become very visible. The logic, the behavior, these you have full control over, given the limits of the platform. But you don't need to care about how it's being run. You just need to care about what to run and when to run it. So yeah, let's just look at a Google Cloud Function in code. I don't know if there's any questions so far, but we can always take them at the end as well. We can have some time for a Q&A. But basically, this is a classic function. Another topic, basically, the way I structure my code is always in a monorepo, which is a whole other topic. If there's people interested in that, my contact details are at the end. Always happy to chat about new ways of doing things. So this is basically a typical Google Cloud Function. And what we're going to do for today is we're going to go calculate the price of a prospect. So this is basically actual business logic that we used at a level a few months back, where our salespeople could actually just, we had a new product on the market, and they just could give us basically two inputs, the number of teachers and the number of students. And then based on that, we could calculate the price of our product. Now, the calculating of the price, as you can see, is quite heavy logic. It uses some configuration from the database, which is our pricing configuration, then mixes that with, so this is basically runtime data, mixes that with the number of teachers and the number of students to come up with a price. So so the pricing functions is quite, so the logic is quite okay, it's quite complicated, but it's very straightforward as well, because it's one by one. So it's step 1, step 2, step 3, step 4. So it's just business logic, and you don't need to be an advanced software engineer to be able to write this. You just need to get the business requirements and write it down. Now, this business logic, so this is now gets put into the data. So the second thing we care about is when to run it. And in this case, we had some sort of a thing where we wanted to run it twice. Okay, so we wanted to run it both on a REST service, so that they can just go on their phone and quickly calculate the price, which is what this thing does. So this is now the Cloud Function SDK, where you can do functions.https, so do an HTTPS call, and the moment you're receiving the HTTPS call, execute this function. That's what this says. So this is a Google Cloud Function. So very different from how you're doing a Docker container, which is always some sort of an app where you're using maybe Nest.js, you're using Express, you're using a server to actually capture all of these functions and then put them together using an API. So you have some controller or something like that that will now redirect you to the functions to execute. At Google Clouds, with Google Cloud Functions or any serverless platform, we just care about writing the function itself. So we don't care about how it will be linked into our controller. Now, what you get is basically on call of this function. I get data and context from the Google SDK. The first thing I will do is basically check, do I have all of the data to execute this function? So I have some sort of a guard. Then I will create a connection to my database, which in this case is Firestore. I will get the database configuration, so the pricing config. And then I will basically calculate the price and return that price as a REST service. So I will basically get a question and response, typical HTTP REST. If I don't have enough information, I just throw an error so that my front end also knows that something is not right. So this is one. Secondly, I also want to track this data into maybe an external CRM. So maybe something like Salesforce, HubSpot, whatever, or our own CRM. And to do that, I basically want the moment a prospect is created in my front end, I want to listen to that document. So this is a second way in which I'm registering the function. Now, not as HTTP REST, but I'm now registering it on the Firestore. So I'm asking if my documents updates, my prospect document updates on Firestore, I also want to execute this price, this function, and change and basically change the data based on so calculate the price and okay, sorry. When a change happens on my database, I want to execute this function again and calculate the price, get the pricing config, calculate the price, and now basically also not return that to the front end, because it's not a front end asking me for that document, it's the database, but merging that price with the prospect object on my database. So that's what this thing does. Okay. So these are different ways in which my behavior is different depending on the use case. So my behavior, the logic is the same. The logic layer is the same. It's just calculating the price. But the way in which it's calculating the price, when it's doing that, will differ based on these types of ways of registering it. So we can already now just take a step back as architects, and maybe after this, before I continue, I will also have a moment to just take some questions to make sure that everyone is still following, because I know I'm going quite fast. But basically what we can see is that, so we have now working code. So if I run, and it's basically just running this thing is as easy as using the Firebase SDK. So that's what the serverless platform now takes care of. They have a CLI which I can just use, and I think I called this project Solid DevFest. So I can just say use this project, and then basically say Firebase deploy. And now I only want to deploy functions because I didn't work on my front end yet. And then it will just take those functions and now run them as an HTTP endpoint, as an a Firestore listener. Okay, so these are different ways. You can go very far with the types of ways in which you can register functions. I've already talked about cron jobs, so also that's possible. You can just do some have cron jobs on there. You can have the pub sub, so when something is stuck to a topic, subscribe to it. You have on write, on update, on delete, on create of all of Firestore documents. And it's basically a platform, as I mentioned. It gives you a platform so that you just have to care about the logic, schedule the logic using their SDK, and they will take care of running it. Now, I don't know, I'm now going to ask the hosts, are there any questions at this point?
So far, we've not received any questions on the comment sections of Discord server. Though I would have a very interesting question, and I've been asked this question quite a couple of times. I've not always had the best answer because I'm not very much into cloud. But I've been asked these questions by very many people, especially by beginners. And it's basically they could not understand the difference between cloud and shared hosting, because they think when you say that in cloud you're using someone else's server to host your code there and run it there, they think I do the same on shared hosting. Does that mean that my shared hosting is a cloud service?
Okay, interesting question. So cloud is basically, it's a difficult concept because many things are cloud. It could be that a shared hosting service is also a type of cloud. But there's, again, cloud evolves. So initially we started out with computers, and everything would just be on a local machine somewhere on a local LAN network, and we would need to call maybe Safaricom or something to open up a public IP so that people could actually access our on-premise service. That's how it started. So that's definitely not cloud.
Yeah.
Everything else is what I would call a degree of cloud. So something like a shared hosting is, it depends. Is it something that already allows you to maybe upload a container? Is it something that allows you to do WordPress hosting, for example? That is more of a, yeah, it's a type of cloud because you also don't have to worry about where the servers are. It's just a plug and play. And that's actually what cloud is about. It's the same as electricity, basically, okay? If I put in my computer into the socket, it charges. I don't need to care about where the electricity comes from. I don't need to care about the power plant. I don't need to care about the dam that's generating the electricity. I don't need to care about how it gets to me. I just plug it in and it works. And the same thing is what we have as an analogy for clouds. But now at another level, I just deploy something. I don't need to care where the servers are. I don't need to care how they're maintained. I don't need to care what the failsafe is, whether they're using arrays, whether they're using failover data centers. I don't even need to care where the data center is. I just upload my code somewhere, whether it's a container, even a virtual machine, even a WordPress or whatever. I just upload it somewhere and it works. And that's what cloud is. That's why cloud is a very confusing thing. Serverless is an advanced degree of cloud, because at serverless, it even abstracts it more than what you would do with a shared hosting. If I do a VM, if I use a VM, I still need to install everything. I still need to SSH into the Linux bash. I still need to install all of these things. I still need to maintain it at a certain degree, because when my Ubuntu updates, I need to go out there, make sure my application doesn't crash. Serverless takes all of those pain. Containers already took sort of that pain away from you, because you were no longer working on a machine, but just working on a container. So I could have a Python container. I no longer care whether it's on which VM it is. I just want the container to run. So that was the second step we sort of took in cloud. I just upload containers and they run. The type of serverless we're talking, this is also already a bit of a serverless thing, but App Engine is actually something like that. You just upload a container and it works. A lot if you use something like GitHub Actions, you would want to do something like that. So you would build a container, then upload the container somewhere when it works. So you can automate that build to really now take away the stress from the developers. Even they don't need to worry anymore about how it's being plugged in. They just need to write the code, and you have some automated script that builds a container and uploads the container. So when Kubernetes, I don't know if anyone has heard of Kubernetes, is actually that. It gives you the infrastructure where you can just plug in containers, and it takes care about swapping them out. Now, Google Cloud Functions is an abstraction even on top of that, where we no longer care about containers even, we just care about functions now. And the functions can be in any language. I have a Python function. I have a TypeScript function, and I don't even need to care anymore about how it's. I just tell it I want it registered like that. I want it to run then, and I want to get the output back like that. So it's getting more and more convenient. The type of plug we put into the wall, but it's all cloud. So cloud is a bit of a fuzzy concept. I don't know if that answers your question. Hello. But let me continue, and then maybe we can take the discussion from there. So what we basically now want to do is, and I don't know.
Awesome.
Yeah, I don't know how long I still have on the session.
I believe now every time anybody asks me those questions, this is. Yeah, that's what I'm saying. Anytime anybody asks me that question, this is the link I'll be giving them.
Okay.
Because the answer was just perfect.
Okay.
So I don't know if Velda has any other question.
Sorry. Currently I don't have a question.
Okay, great. What I don't know how much time I have left. Do I? Because I have quite some stuff to cover, so we can look at how to continue the session based on how much time I have left. Do I have till the end of the hour?
Yes, till the end of the hour. Yeah.
Oh, okay.
Oh, and there's some questions coming in. Sorry to interrupt, but there's a question that has just come in from Collins Juma. So the question is, I have interacted with DigitalOcean, and once you created a droplet, you can as well map. I don't know if that's the question, but there's another, it's a continuous one. Does GCP provide same functionalities? Okay, let me read the whole question for you. So I have interacted with DigitalOcean, and once you create a droplet, that is an IP address is generated for you. You can as well map and mask the IP address. So you can use a domain from shared hosting. Does GCP provide same functionalities?
Yes, GCP is very, very large. So if you go to GCP, there's many different types of things that GCP does. So a droplet, I don't know if it's probably a container. It's been a while since I've worked with DigitalOcean. I think it's a Docker container. GCP has something like which is called. So you see, GCP has quite some functionalities. They have something called App Engine, and on App Engine you can just upload a container, and then it will basically run for you. And then it's very easy to now link a domain, a name next to it. So another thing App Engine has, and this is basically, it has something called Cloud DNS. So you could both link. You can open up a public IP. This is called another service of GCP, which is called Elastic IP. Basically allows you to open up a public IP. Then you just link your shared hosting to it. But GCP goes even further. You can run your whole DNS server, whole virtual DNS server straight from here, using Cloud DNS as well, which is something we use quite extensively. I'm trying to find it again. There's quite some services, but yeah, that is definitely possible. It's just about opening up a public IP, which Google Cloud does for you, and then you can just run your whole domain. You can just link it from your DNS server, or you can, the way we have it here, run a whole DNS server straight from Google Cloud.
Okay. So the next question is, where can people get the code example being used? So where can they access your code from?
So I'll actually upload all of this to Google to GitHub. So we have as a level, we have our own GitHub repository, which is called @yote. So we have some so you see our logo come back here. We have some open source projects on here. The ng solid mono is actually one of them. Now this is what we're doing. We have two types of things. So we usually work in something called a mono repository, which is what you can see here. So we have our applications, so different applications. It could be a front end, it could be a back end. We have them all in one code base together with basically our libraries. So our GitHub mono is actually to be used in a mono repository, but then we're also publishing npm packages where you can just pull these things in. So this whole mono repo is something I'll put online after this this talk. And then you can just play around with also what a mono repo looks like, how to do basic functions, and then basically how to work from there.
Awesome. So we're going to share all that. Dennis Kevenji, you're going to share all that after the session, and then we'll let you know from our platform where you can access the code examples. Yeah, I think we can go on. We have like 20 minutes or so. So yeah.
Okay, that means I'm gonna go a bit fast right now. But what we basically, the goal of this this talk was now to look at, okay, how do we use these platforms in such a way that we're no longer stuck on a certain type of platform. So one of the things me as an architect and as a developer I want to do, I don't want to be stuck, and I don't want to be vendor locked into a certain platform. That's also what this whole the whole evolution of cloud basically leads to. If you look at containers was developed for the fact that I don't want to be stuck to a single platform. I don't want to be. I want to also be able to run it on my Windows machine as well as run it in the cloud. And I just want to have that container, which is the virtual machine that does that abstraction for me. Now, when it comes to the way in which all of these platforms are being developed, so all of these Google Clouds, Lambda, Google Azure Cloud Functions, Alibaba Cloud Functions, they all come with their own SDK. So their own SDK, which in this case is an npm package, Firebase Functions, Firebase Admin. And when you build code on top of the platform, you sort of get stuck into that SDK. So for example, I have this calculate price of a prospect function. I immediately get linked into the functions SDK of Google Cloud, which means that if I later want to now move to AWS, I have to rewrite all of these registrations to not be on Google Cloud, but to be on AWS. So I can already maybe anticipate it a bit by separating the logic, the pure logic, which is what I did in this application. I can already anticipate it by separating the pure logic into its separate functions, and by being able to then import those functions separately, but I still will need to rewrite the way in which I register it onto the platform. So the one advice I can give you as aspiring architects or as software engineers is basically never trust a third party. You always want to write your code in such a way that when you need to switch, you can. Because when you go into production, especially in very large systems, the most difficult thing to manage is code that's not yours. So what we will basically do today, and I'll go through it very fast, is we look at what do these functions look like, what are typical common patterns, and how can we develop our own library that basically allows us to just swap out the whole platform entirely without really having to worry about when we want it, basically. So what we're basically going to do is create that proper separation. But then develop our own library that builds sort of a layer in between behavior and logic that allows us to now use this library to schedule our functions, but not be dependent on it. That's basically the goal. I'm going to go through it a bit fast, but it's basically a library that's open source that we've developed that you can play with yourself. And it's basically called ngFire Functions. So what it basically does is we looked at what are the common patterns, as I said, that come back in these cloud functions, and how can we now develop an abstraction over it that basically writes this code as a result, but that doesn't get you stuck on it. So it's like what we basically are going to do is like building a front end. When you build a front end, the first thing you do is you draw what you want. So you have some piece of paper and you draw, maybe I want this screen, I want a menu here, I want a component, a card here, and then you go and implement it. What we're going to do is now the same, but instead of now having it as a front end, we're actually going to look at the code. So this is what I want to write, okay? This is the front end I want to generate. So we're going to go into a bit of what I call meta programming. So we're going to program things that create code. It's like a compiler. That's basically what a compiler does. Huh? A TypeScript compiler takes in TypeScript and writes it to machine code that your machine can read. Similarly, what we're going to do here is we're going to take in TypeScript and we're going to write it to TypeScript. Okay, it's a bit of a mind F, but it's not as hard as it basically looks. So the first thing we need to do, and now I said it 3 times, so now I'm going to explain it, is look at what steps does such a function exist out of. And the first step it exists out of is the registration phase. So basically we are registering this function on top of a platform. This is really the behavior layer. Inside of the behavior layer, we now have our data layer. We need to get the data that we want to use. We have some sort of a guard, which is a card. What is needed to execute the function? What things do I need to? It could also be user permissions. It could be something else. But these are common patterns that usually come in a function. The first thing you do is check: do I have the necessary things to execute this function? And then there's the actual code. Finally, there's what needs to happen once I have the code. So this is back behavior. So you can see that we basically have 2 layers of behavior in which the logic is squeezed. So what we do next is basically we're going to define these things. So the first thing we're defining is a Google Cloud function. Okay, a Google Cloud function is just a class we create that takes in all of these separate. So this is the constructor. It takes in all of these things that you need to register the function. So it needs a function name because it needs to run something on basically your Google Cloud. If you want to run calculate price, you need to be able to have that calculate price name somewhere so that we know the HTTP endpoint. This is the interesting part. It has a registrar. So this registrar is something of a type function registrar, which I'll get into, but it basically is the same as this thing. Okay, functions firestore.document .onUpdate. It's how we will register the function that needs to run. And you can see that it's the function on call. There can be multiple ways in which we want a specific function, in this case, calculate price, to run. So behavior can be multiple. There's one logic, there's multiple runs. Then there's a list of guards. Okay, what things do I need to be sure of before I can execute the function? And then there's the actual logic. Okay, so what we've done is we've looked at this code and we've mapped that structure onto an object, which we call a GC function. So the code itself is mapped onto an object. What I just suggest is just look around in the code to really understand. We try to document it a bit, what this concept means, but basically it's just that this whole thing has been conceptually mapped onto an object of GC function that takes in some data, so the data expected by the function to execute, and that returns a certain result. Okay, so we take in some data, which in this case is the I think I have it here, the price calculation requirements, which is again that number of teachers and number of students. So we have a function of price calculation requirements that returns the price, so a number. Okay. If you're not following, I still have some time for questions after that. And then we have some common tools we use, such as a logger. Instead of always using console.log, what if console.log suddenly tomorrow becomes console.write? Then we basically have our own logger that does the translation for us. And we have some tools as well, such as getting the repository. So also our the database layer itself, we won't even be dependent on Google Cloud anymore. We just have our own data layer, which is this one, which we then again in one code file translate to Google Cloud. So that means that all of these things, this Google Cloud function, if we now want to write an AWS function, the only thing we need to do is implement this interface of Google Cloud of a function from T to R, and then have that that build method. So the build method now is where we take a Google Cloud function and we turn it into where we take our own function and turn it into a Google Cloud function. Okay. So this one I won't go into much because it uses basically this is the logic. It basically wraps functions around each other to then actually register it onto Firebase. But as you can see, it's only 4 steps that are needed to actually turn any of our logic into a Google Cloud function. So if we want to now move it to AWS, we just implement the same for functions, but now looked at AWS. Before I actually go there, maybe just I think I talked a bit about this. So basically, our logic is mixed in with our behavior because of the way in which our Cloud Function 1 and Cloud Function 2 are shown. So our logic, which is our behavior, basically the type of database we use, when it needs to run, what it needs to do on return, is mixed in with the actual calculation, and that's what we want to avoid. Basically, that's what I'm talking about, how to avoid. So architecture is what can basically save you from that and make sure that you're not committed to one specific code stack forever, which as a business, basically you need to, you never want to be stuck on one external party. So right now, so what we're basically developing is all of these layers using the GCP function, which I just showed you, the one we write ourselves. We basically create a translation layer to work with different SDKs. And then if we want different SDKs later, the only thing we need to do is change that translation layer to now use, for example, AWS, but our code remains the same. So basically, there's different types of things that we will define at different levels. Sorry. There's the handlers, which contain the actual code that needs to be executed. So what does it need to do? Which logic does it need to have? So as you can see, okay, where was I? I was here. There's a very simple function handler that takes in T, the data expected, and returns R. And it has one method, which is basically the execute. So our developers will always develop just one method on Google Cloud, which is the execute. So you will overwrite this class to create maybe a price calculation handler. And it will take in the data, take in a function context, which we've also defined. Oops, big definition is what I wanted to do. Which we've also defined. Yep. As just having some parameter context. So for example, is authenticated, is this an authenticated user that's executing the function or that's calling the function? What is the user ID? So such things, it just gives you the context and maps it onto things we need to actually execute our logic. It just maps it onto the handler. The library takes care of all of that for you. And then the tools, as I said, the logger is in here, the access to the database is in here, and things like that. So when we implement these function handlers, they will actually contain our logic. From there, we use these registrars, which you also saw is one of the things the GCP function takes in. So it takes in the handler, it takes in the ways in which it needs to be registered to basically register this function now onto the platform. And then finally, the registrars, we no longer care about the platform, the framework we develop as architects. The registrars make sure that the handlers get registered onto our platform in the way we want it. It also enables us to work with multiple platforms at the same time, because the only thing we need to do is link the logic to a different handler. So we could have functions running on AWS and running on GCP at the same time. Well, for developers, it's all the same code they're developing. So what it basically, what these registers look like. Basically, you have different types of registers. They're all function registers, and they have a register method, which is registers the past function as a cloud function. So you can see it returns. So this is the one that is actually, if we look at our old code, this is how we will translate the line of this line. Basically, this is this line on update on that. That's the registrar. So the registrar can be a Firestore registrar. It can be an HTTPS registrar. As you can see, we have many different ones. You have the pub sub. So how do we register a pub sub function? What needs to happen to translate the context of the pub sub to something that our developers can read, so something that maps onto the handlers? What needs to happen after? What if an error happens? For Firestore, we have different. We have the create, we have the delete, we have the update, we have cron jobs, so which need to run in a certain time zone at a certain time. So it's very simple. We're just using the same library as GCP is using, but we're now mapping it onto our own code, which we have control over. So the only thing we need to do to have an AWS cron run is basically change out this register function, but our developers will still now use the cron register. And then we have guards. All of these things they're all very well documented in the library, how it works. I really encourage people to also look at what the code looks like instead of just using the top layer. But then just to close it up, because I'm very short on time, I should have budgeted a bit more time. But basically, what we want to do is now have a new function called TS, which will basically start with a function handler. So what I will now do is basically take this code and look at what it looks like in the new framework. And I will export the class calculate price handler, which is a handler of type, and then we have the model. We have the input, and we have the output, which is a number. So it takes in the price calculation requirements, and it returns a number. So it's saying now it's not implemented well. So what I need to do is basically implement the class. I need to implement the execute method. And what I will basically do in here, I have access to the data, I have access to the context, and I have access to the tools. So what will happen here is basically this function, this logic that we have over here, which is the inner logic. The first thing I want to do is get the pricing config. So I will basically say const pricing equals context. Sorry.
Hey, Yente.
Yes.
I'm sorry, but time is not on our side, so we need to get into the next session. So okay. I might have to cut you short.
Okay. I don't know if I still have 1 minute.
Yeah. Please finish up on it. Yes.
Okay. So basically, what basically the goal is that we have our whole own library, and that this whole logic can now be registered onto multiple functions. So I have the whole logic, which is in my cloud function here, that I will basically put in calculate handlers, and what I will then basically export is not the direct SDK, but I will export new DC functions. Have a name, which is in this case calculate price. Have a registrar, which is the thing that we've now automated, which is basically new REST registrar, for example. So this will be a REST endpoint. It has guards if you want it, and then it basically has this calculate price handler to link the logic. So what I can basically do is have a REST function and have just give me a second, and have an wait. Now I need to update registrars. I think an update registrar if something happens to this collection, and the same handler will basically execute. So our logic is separated nicely into handler classes, while the way in which we register it is separated completely from the platform. So that's where I wanted to end. All of this code will basically be online. If you have any questions, just my contacts will be shared, I think, later in this call. But yeah, just reach out, and I'm very happy to help you out. So thank you for this session. If there's any questions, please reach out.
Okay. Thank you very much, everyone, for listening to us, for following the session. It was an amazing session. Thank you very much, Yente, for the amazing session you've had with us. And because time is not on our side, we'll have to quickly finish up on this session as we welcome our next speaker for the next breakout session from 11 a.m. And so it has been nice being with every one of you. Thank you very much, Yente, again. And we hope to hear more from you in upcoming events and in later days. So that's it from us. Thank you and see you. Stay tuned. We'll be back.
Hello there. Hey, team. I hope you can hear me. So the next session we have is from one of our very own. His name is Chet. So Chet is at the developer relations team at Google. And we're really sorry he couldn't be here with us, but he recorded a really good session. And that's what we're going to play next. So stay tuned.
Hey everyone, I am Chet Haas from the Android Developer Relations team. Organizers for including me in your event. And I want to point out that I would really, much rather be there in person live because that's always more fun. But it's great that we have these virtual events where I can kind of be there anyway. I also want to say I would really rather be doing this live, but when I heard that the time in California terms was in the middle of the night, I realized it'd be better to do it in video form rather than fall asleep during my presentation. So please excuse the pre-recorded video nature of this, but I hope you learned something from this presentation. So I want to talk about Android development today. The reason I want to do that is I think that there is so much information out there that it's helpful to get sort of a mental model of how we put it together on the Android team and how we view all of this content as in terms of how developers should consume it and what you should learn and what you should do for writing your applications to make them better. The really cool thing about Android is there is so much information out there and you get to use so much of it in writing your applications. The problem is there is so much content out there to learn and use. So how do you get a handle on what it is you're actually supposed to be doing? For example, all of this stuff and more and more and more all of the time. Right? So at the same time, we have these platform releases coming out generally annually. We have bug fixes, we have important new functionality, we have new device capabilities, we have these Android X releases, all these unbundled libraries coming out and the tools coming out all the time, new technologies coming out to learn and to use. And this ecosystem, this vast ecosystem that we have in Android of all of these devices and all of these manufacturers and all of these countries and locales, and how do you get your hands on how to write great applications given all of these limitless possibilities that we have in Android? So what are you supposed to do here? So I look at this talk as my to-do list for the stuff that developers should learn and use. What does the Android team think is important for you to really focus on to write better applications? Or at least specifically, what is it that I think you should focus on as a part of that team? So there are kind of a couple of major areas that I want to call out here. One is the platform, right? We do release new platform capabilities. So what is it in the platform that I think is important for developers to continue to tune into and to recently tune into? So some of this is specific to recent events as Android 11 came out. But in particular, this first one, I see this as a priority 0 item is stay tuned into privacy. For the last several releases, we have come out with changes in the privacy area because I think we all agree that user data is really important. You want your data protected. I want my data protected. All of your users of your applications want their data protected, right? They need to know that their data is safe and they need to know what is going on with their data. And so we've had a bunch of changes in the last few releases, and I anticipate that will continue in the next few releases as we continue to see areas that we really need to button down and protect data for those users going forward, right? So some of the examples of that in the recent releases include location, buttoning that down in every single release. There were various ways that applications could get location. Well, the user didn't necessarily want to share their location with applications. So let's make sure that it doesn't get shared when it's not appropriate, or that the user knows and actually agrees with that location being shared. Storage, making sure that their files and their data is safe there. Microphone and camera capabilities, make sure that they know when those are being used. Enough information from your application, and then they say, yes, you can use this permission, and the appropriate time to use that permission. You can use that permission in the foreground, in the background, at all times, or just when the application is being actively used. The second item, and some of these are specific to new capabilities in Android 11, but also going forward, is just the usability of your application with these platform features. Some of the recent features were around people and conversations, as we realized that more and more all of us want to stay tuned into all of the people in our lives, whether it's coworkers, whether it's friends, whether it's family that happens to be friends as well. Whatever it is, those conversations tend to be the most important things that we do on the phone. So we're trying to make it easier to use that information and to propagate that to the user in an easy way so they can get back to those conversations really quickly. And that includes some of the new notification capabilities. So you can click on that notification and return to an ongoing conversation. You can see that notification in a really obvious, prioritized way in the notification panel. And bubbles, which is UI that can show up all over the device, again, allowing users to really quickly and easily get back to an ongoing conversation with the people that are important in their lives. Also, smooth experiences in general. And this is in general for using facilities such as animation or making sure your performance is adequate so that we're not janking on the screen and that the user can really enjoy the experience of using your application. In Android 11 in particular, one of the important features that we enabled here to help was the Synchronized Ime Animation. So if you imagine a chat application, when you click on the text field to enter some text, the keyboard will animate into place and your application snaps because you had no facility for finding out about the keyboard animation. Now you do, so it's good to actually integrate that so that you can actually smoothly transition your application content as the screen transitions and animates around it. The second major area that I want to talk about is what we call modern Android development. And rather than try to explain it, I will just read a quote because I thought carefully about these various words. Development tools, APIs, language, and distribution technologies recommended by the Android team, that's us, to help developers be productive and create better apps that run across billions of devices. So we've used this phrase a few different times, and we mean something in particular when we use it. And I'm going to talk through some of those elements here. So modern Android development, I think of it in terms of these four pillars of language, tools, APIs, and distribution sitting on top of the foundation of platform and play. We assume that you're using the platform capabilities. We assume that you're using general play distribution technologies like the Play console, but we're going to talk specifically about these other elements that are sitting on top that you, if you are not using them yet, you really should to make your development lives easier and to make your applications better. So first of all, let's talk about modern language. Java is great. But we believe that Kotlin is better, especially in the long run as we enable more capabilities and new libraries that take advantage of some of the unique aspects of Kotlin that will make it a lot easier for you to write as well as to maintain and make a more robust application. There's less code to write in general. It eliminates a lot of the boilerplate code. You can catch your errors at build time instead of runtime, which is awesome for your users. Wouldn't you like to catch that nullability issue in the IDE instead of having your user catch it in a crash? There's very expressive language features and really interesting capabilities like extension functions, which allow us or allow you or allow external developers to actually add to the API in a way that doesn't require platform upgrades, right? And concurrency, I think, is really powerful. I'm going to get back to that in a minute. Also, there is new functionality that we're enabling in things like Jetpack Compose and the Paging 3 rewrite that take advantage of these unique aspects of Kotlin to enable a much better development experience. So concurrency, we also believe, sort of a priority one, you should learn coroutines and flow because concurrency programming, which is a necessary part of UI development at the very least, where you really shouldn't be doing things on the main thread, so you have to go to another thread and then you have to figure out how to communicate back and forth, and it tends to cause really complicated code. Coroutines and flow enable a much better coding experience as well as maintenance experience. Just reading the code and understanding what's going on is a lot easier. So learn Kotlin, but also learn coroutines and flow and integrate that into your development experience to make your code writing as well as maintaining a lot easier. All right, second is tools. You're probably using Android Studio already. We encourage you to continue. We also encourage you to learn new tools that keep coming out all the time that make things more efficient for you. A lot of those tools integrate with a lot of the APIs that I'll talk about in a minute. So when we come out with new functionality in these unbundled libraries or platform libraries, we also come out with tool functionality, and these integrate together. So you can use the design tools, you can also use coding, you can go back and forth, use them both together to make it much easier develop these capabilities in your application, but also to just create better applications in general. This includes things like the navigation editor for creating flows through your application, constraint layout editor to make it much easier to design what your UI looks like in a very rich and powerful way, motion editor, which is an editor built on top of motion layout, which is a subset of constraint layout. And this makes it possible to not just design a rich UI, but to design these transitions of that UI and the animations that take you between states of that UI. So you can imagine constraint layout as kind of the states and transitions on steroids, right? Really powerful mechanism for saying this is my before, this is my after, and animate, but you can customize the animation through constraint layout and motion layout and motion editor in a really powerful way. And profilers for finding out actually what's going on in your application, how to improve the performance and make things much smoother and more usable for your users. Visualizers for things like database capabilities, as well as build issues that you're having, and more tools all the time. So stay tuned into the tools. Third, modern APIs. So we think of this as Jetpack, but really a subset. Jetpack is huge. There are so many libraries. There's like over 80 libraries that we ship there. But there's a core subset of those that are specifically aimed at making development easier, especially in complicated areas like life cycles. One of the major advantages of these libraries, of course, is that they're unbundled, which means that they work across many releases, many of them all the way back to API 14. Some of them, like Camera X, go back to API 21, which is where a majority of our users are right now. So you can choose according to where your user base is. It's easy to use these, or I should say it is at least easier. That is the whole purpose of a lot of these architecture component libraries, is to make really complicated things much easier for application developers. So when architecture components, I'm talking about things like live data and view model and navigation, work manager, things where we looked at a specific area that was difficult to develop for, and we developed these unbundled libraries to make it easier for you. On the UI area, it includes the stuff I was talking about before for constraint layout and motion layout, as well as those editor tools that I talked about. We also encourage you to check out the new libraries as they come online. This is an area of very active development for us. The whole space of these easing developments issues for you. In particular, there's the Camera X library currently in beta, heading towards stable sometime. So you might want to check that out in the meantime. It's an API that makes it much easier to develop camera applications. It also embeds a lot of the workarounds that developers have to use across this vast ecosystem. Hardware devices behave differently in areas like cameras, and it's difficult to handle that in your code. So we've started handling that in the Camera X library instead, to give you one API and one approach to use, instead of figuring out different solutions that you need to use based on what runtime device you happen to be on. HILT, if you use dependency injection, we recommend this as the approach to use. Even if you're currently using Dagger, it may be worth looking into migrating to HILT to make your code more consistent, more streamlined, and easier to develop as well as maintain for large development teams. Paging 3 the paging library just got a major rewrite in Kotlin, integrating coroutines and flow for this inherently asynchronous operation of streaming data in from these database objects into Recycler View. So that's worth checking out, as well as Jetpack Compose. Huge new development ongoing. It's been developed in the open for a while. Recently went into alpha. It is the future UI toolkit for Android, so it's worth tuning in at some point to figure out what's going on there and see how you can use this new programming model, at least new to the UI toolkit, of reactive programming, which is really powerful, we think, for doing inherently asynchronous programming, which is required for the UI model that we have in Android. And then finally, distribution. So here I really mean specifically Android app bundles. So you can see a handy little animation on the right, the difference between the APK model that's classic Android and the app bundle model, where with app bundles, you upload a single app bundle and then the Play Store will figure out what's actually needed on the runtime device. So instead of you either having a monolithic API, which is really huge for all of your users, or many APKs that then you have to somehow manage, then you just upload one single bundle, basically a monolithic bundle, and then Play Store figures out the specific APIs that are needed by the users that actually download your application. On average, we're seeing savings of 20%, just automatic, by not having to send down the information for, let's say, locales that are not being used on the user devices, or form factors, configuration information that are not needed on that runtime device. So they stay on the server and the user doesn't have to download and install them. An important point to note here about app bundles is it is required for new applications as of the second half of 2021. So right now, optional, check it out. I encourage everybody to use app bundles now. Eventually, you will need to use them because that will be the way that you interact with the Play Store for your application. So for all this modern Android development stuff, there are the pillars and the basic technology that I talked about here. And there's a site on d.android.com, Modern Android Development, where you can learn more. The third area I want to dive quickly into, as I said, it's really complicated to figure out what's out there and how you find it and how you use it. So I want to talk about the areas that I think about in terms of where we publish this content and where you probably want to look to learn information. So the P0 here is find the stuff that's out there already in areas that you are already using and may need to know more about. First of all is Android courses. We offer everything from beginner to advanced courses in everything from Kotlin to Java, UI stuff, storage, like all over the place. We've got all kinds of courses that cover all kinds of information in these really sort of broad swaths. So especially if you're new to an area, it's kind of helpful to work through with the combination of sort of code lab and then video instruction to really get a handle on how things work and how things fit together. In fact, there's a new course there called Android Basics in Kotlin, where you don't even need programming experience. You can, during the course of this course, actually learn coding as well as Kotlin as well as Android all at the same time. And also, I should point out, it's free, so check it out. Code labs. So this is kind of the underlying structure that we use in the course. You can think of a course as being video instruction layered on top of a code lab. Well, if you want to skip the video instruction, just sort of dive into the code, then we have these step-by-step guides that help you develop an application in particular areas to learn specific technologies or specific flows through the Android stack. We also have samples. If you just want to see some code and see how a particular thing works, it's worth checking out the Android samples. We also post technical videos on a continual basis to our YouTube channel, which is the Android Developers channel. Very technical stuff, some conference talks, some higher level overviews of releases that just came out, new features. There's technical deep dives in particular areas, all kinds of stuff there, worth checking out the channel and poking around and watching some stuff. And articles, sort of on the written side, we have the videos, but we also have these articles that we publish. Medium is where we publish our technical articles, where we'll have deep dives on specific feature areas with snippets of code that you can copy and paste. And then we have this podcast that I host with a couple of colleagues where we talk to people generally on the Android team about how stuff works. It's not about how do I use the specifics of an API, but rather how is that API implemented? How does that fit into the rest of the system? Why do we design it that way? And it just helps us, as well as hopefully you, understand how Android as a whole works. And I would also put a little plug in there for a series that I've started producing in the last year called Now in Android. I do find it confusing from the outside to figure out what is new. There's all kinds of releases coming out. There's articles coming out, all these code labs and samples, all the stuff that I described on the previous page. All that stuff is happening all the time and more. I think it's really confusing on the outside. It turns out it's also confusing on the inside. And so every 2 to 3 weeks, I'll go in and I'll dig around and sort of find out what's new. And then I'll put it together in this article, as well as video, as well as podcast form, and publish that. So if you want to just keep tabs on what is going on in the Android universe and what is new and maybe potentially interesting or useful for you, tune into the Now in Android series in article or video or podcast or all three form, whatever works for you. That is it. I want to thank you again for allowing me to talk to you. I want to apologize again for this being a video, but just imagine me being live somewhere asleep in California at this time. Thanks.
Great. Great. So yeah, that was our session with Chet. Thank you so much for tuning in. I guess that's the end of the session. As he said, he apologizes for not being here with us, but that was a great session. We can attest to that. So thank you for tuning in, and see you on the next one.
Hey, Bella.
Hi.
So it looks like we have come to the end of our cloud breakout sessions. And
Oh, too bad.
sadly, would have loved to do more and more of them, but because of the time and other factors, we'll have to end the breakout sessions now.
Yeah.
So for us, it's just to thank everybody who is watching this, whether live or later, for joining us, for learning with us, and hoping to join and be with you in the future. So up next is going to be our closing keynotes in the main session. So we are going to probably leave this one running for a bit, and then at 11:40 we're going to have the closing keynote by Irene, and then we're going to call it a day, call it a year with DevFest.
Well, I just hope that the next have to do it virtually. We can do it physically because this is their best.
Yeah, I miss the physical sessions too. The crazy, the hype, the food.
Yeah.
But then now we have to do everything virtually. You have to have a virtual after party, something that we've never had.
Yeah.
By the way, if you're not on Discord, below the screen going across is the link to our Discord channel. Things are going crazy over there. People are having fun. It's what I'm looking on my second screen actually. So we have an after party channel. We have channels for all these tracks. Like for example, this is a cloud track. We have a channel for the cloud track. You can go there, ask the speakers. The speakers that we just had are there on the cloud track. We can go and ask them questions individually or ask the rest of the community. Have such discussions and get to learn more. And so we'll have an after party later today. Join in there with your earphones. Join us as we have fun. We've been having fun the last 2 days. It's been crazy. So today will be the final closing day. We expect it's going to be even crazier today. And so I think that's it for me, Velda.
Yes, we have really enjoyed being hosts for all the sessions since day one, and we surely hope that maybe next year we can do this physically so that we can get to interact more. And I mean, the first is that time that we look forward to, like this particular talk and conference talk. I don't know, I just feel so excited, but I also feel so sad that it's the last day. So sorry, but hopefully next year we're going to do it physically and get swag instead of getting virtual badges. So that's also something. So yeah,
Yeah.
enjoy.
I miss the swag.
You'll get DJ.
I was joking with my friend that I've not bought t-shirts for the last 2 years. Because of events going. yeah, I've not bought t-shirts for the last 2 years. I've always had t-shirts from events. So and the worst thing is that they're almost all black, so you never know. I have sort of a uniform now.
Hey, please change to white. Bring it up with
even the t-shirt I'm wearing now is DSC. So it's crazy.
Yeah.
So, but this year
So
I've missed out on a lot.
Yeah. Okay.
Yeah.
Oh, I wanted to add, I don't know if Getty wants to say one last thing, or we could just end it here. But we have like a few minutes before we join the
I have
keynote, since the
few
keynote
more
is,
minutes before the keynote. Yeah.
yeah. I don't know.
Hey.
Hey, Getty.
Hello. Am I on mute? No, I'm not. So I just want to say thank you to everyone who made time to join. It was a good session. Really sorry again, Chet couldn't be here with us, but it was good overall, right?
Yeah.
Yes,
Very nice.
definitely.
Great.
We're just
So okay, awesome. So I'm just going to leave the link here for the session that will have the closing remarks, and then we can join in at 11:40. I hope that's okay with you.
Yeah, it's just 10 minutes from now. Leave it on not the StreamYard link, post the YouTube link.
Oh, sorry. Wait, there's no way you
Post
can
the
really.
StreamYard link.
All right.
Post the YouTube link. Yeah.
So, you guys, before we leave, I'd like to know which were your best moments through the first season. So, which were your best sessions?
Ruby can go fast. I'll go after Ruby.
Oh,
Okay.
wait, it's for us. I thought it was for the. So, my best moments at this the first were on Friday. On Friday, we had a really amazing after party. I was the DJ together with Ivy. It was crazy. I mean, I couldn't get myself to get out of that after party till it ended. It was just super awesome. The other time I was, yesterday when I was moderating these sessions together with the speakers that we had then. I really learned a lot. I'm normally not an Android, not a cloud guy. I've done cloud, but it's sort of on the side. I'm a web dev. But yesterday I really got a lot of insights on cloud, and I think it's probably going to be the next thing that I start learning or doing more often from now on. Yeah.
What about you, Getty?
Okay, so I personally enjoyed the WTM session because we had food. Sadly for all of you guys. Yeah, so we had a small.
That saddens my heart because I didn't have food.
I know. For everyone except always had because they weren't there. So I had a really good time. We had a good discussion at the end of the session. So yeah, that was my favorite moment. How about you, Velda?
I think I'll also start with WTM because I mean we had free food from Uber Eats, so it was like really amazing. And apart from that, the session was like really awesome. Like all through the sessions were, I really enjoyed every single session for the WTM dinner and also for yesterday's web sessions and keynotes and also today's cloud session. So yeah, I've had really good moments. And after party, Ruby, please, we gotta make this strong.
We actually have a Google Docs with a playlist for suggestions. So if you want to give us suggestions of your music, I can give you the link. Then you're going to have all that in the after party later. Yeah. Also, there was one. You two know this, but there was during this session. There's a time I almost. That was one of the craziest moments I've had today.
What happened? What happened?
Almost showcased his things.
No. That was one of the craziest moments I've had today. Yeah.
How did this even happen?
I don't even know. I
didn't know I was added to the stream. I thought I was not live. But then I was.
Yeah, I think because there's a time I removed you from the stream and I was like, Ruby, what are you doing?
Yeah, it was that time. Yeah. Crazy moments. I think I'm going to remember that for the longest time.
Sorry about that. Really sorry.
It happens.
My moment today was I was having a snack And then I forgot to like switch off the mute and the stop cam. But the good thing is we were not live. And I was like, oh my God, people have seen me eating during the live stream. So the good thing is we didn't have like, we had not started streaming. So I was like, good. I don't have that embarrassing moment on YouTube forever. Yeah.
Yeah, it's the same. I was having yesterday. Yesterday I was having lunch on the stream. So there's this one time I had to pretend that. Is this one time I had to give an excuse that my internet was lagging, but in the I wanted to first swallow the food before I talk. This whole Delphist, it has not been physical, but the whole drama inside these live things has just been crazy. Very crazy.
From organizing to the action events, it's been crazy.
Yeah, super awesome. So I think we have like 6 minutes left. I'm going to ask you to allow me to jump off, go coordinate with the rest of the guys before we go in for the final keynotes.
Okay, I think we should just end the call because I also want to take 5 minutes.
Yeah, so guys, see you on the closing keynotes, and thank you for being with us. See you next Devfest in Nairobi.
Yeah.
Or in Nyeri.
Yes.
Or in Kisumu. I'll be in all the Devfests, the 6 Devfests.
This next year, you're actually coming to attend all of them as a speaker or as an attendee?
He should be a speaker.
Of course, I'll be a speaker. I want to be a speaker, but I don't know what I'm going to speak about yet. But the whole experience of organizing Devfest Kenya this year, makes you always want to do more and more for Devfest. So I'm probably going to be doing more. We actually had planned to go to Devfest Tanzania Devfest Tanzania this time. If it had been physical, we would have wanted to go there. And had plans about going to Devfest Bujumbura. I would also probably have gone there, but COVID happened, so we'll wait till next year to do that.
Yeah, I feel like as developers, it's really like Devfest is like our Christmas. It's not that we just go and see people learn things.
It's the most hyped part of our year. Yeah.
But it's so sad. It's ending today, but it's okay. We look forward to next year being physical. Hopefully, all this pandemic will just calm down and wrap itself up and just leave.
Yeah, I'm pretty sure it will probably be gone by that time, or we'll have had a vaccine by that time. Let's hope. And but anyways, whichever comes, we'll be ready for it.
Yeah, sure.
Okay. Yeah. Okay. So
bye.
Let me jump off. See you later, guys. Bye.
So the link to the next session, which is the final session, is on the chat section. So we've just shift to that one at 11:40. Sawa?
Yes.
Okay. Bye, people. I'm ending the broadcast.